Okay, so next topic that we are going to discuss, the last topic from the motion in a plane or motion in two dimension, that is relative velocity in two dimension. Relative velocity in two dimension. Look at that. So first, relative velocity in two dimension. One dimension relative velocity we have seen. For example, a car is moving in this direction, v with v1, and another car is chasing it with v2. Then in the same direction, one dimension only. So then we know that v2 minus v1 is the relative, or v1 minus v2 with respect to each cars. Alright. So that is the first thing that we studied. But here there is an angle. Like there is two velocity vectors are at an angle theta. Then what is the relative velocity? v12 is equal to v1 minus v2. Suppose if they are at an angle theta, then the magnitude will be root of v12 like v1 square plus v2 square plus 2v1 v2 cos theta. But there is a small problem as well. Listen, like here the relative velocity will be in this direction. Okay, this theta also you can find out, or this alpha also you can find out. You know that we already seen this where in vectors. This is purely vector only, purely vector. But I am just introducing some sort of problems that you need to understand, because this multiple like type of problems you can expect. For example, here we are discussing rain, swimmer, satellite, these problems. Maybe in a new question paper you can expect a new question as well. Did you understand my point? So the thing is, relative velocity of a satellite, first of all, v satellite with respect to Earth, VSC is equal to Vs minus Ve. This is when the satellite is moving in the west to east, that is in the opposite direction of the rotation of Earth. Then the satellite would be here. Okay, satellite has velocity in this direction. The Earth is also rotating, even the opposite direction. Then this will be Vs minus Ve. Suppose if east to west, then Vs plus Ve. Okay, then minus will be there. Alright, that is the first thing. Next is relative velocity of rain. This is a board exam type of question, not like very important question in the perspective of NEET or JEE. But still, what is the relative velocity of rain with respect to man? Vr minus Vm. So you can see that here rain is coming downwards and man's velocity is in this direction. So the umbrella we should keep in this direction. You know that, you studied already. So here what is the value? The magnitude is equal to root of Vr square plus Vm square. Why? Because the angle between them is equal to 90 degree. That is why. Here also, if the angle between them is 90, root of V1 square plus V2 square. You know that. Now, what about theta? Theta is equal to tan inverse of Vm divided by Vr. Tan inverse of Vm divided by Vr. In that angle only we should keep the umbrella. Alright. So next is relative velocity of swimmer. This is very important problem, and we will have a little bit extension of this problem in the next video. That is crossing the river problem. Crossing the river, in which velocity the man should, or in which direction the man should cross the river to get the minimum distance, or to reach in the minimum distance, or to reach in the minimum time. So that is a different scenario we will discuss. So relative velocity of man with respect to swimmer. Suppose there is a river is there, and river velocity is Vr, and man's velocity is Vm. So if they are in the same direction, Vr plus Vm. Okay. So otherwise Vm minus will come. Alright. That is the very important thing. Nothing else is there in this topic. And as I told you, the river crossing problem is a little bit important. You can give a little bit gravity to that topic. So let's see in the next video. Okay. Thank you.